So hopefully our last video wasn't too incredibly painful, showing you how to make a multi-pair cam assembly. But I wanted to make a quick video explaining how to choose your angles if you're picking your own cam. And you might just do the exact same as you did in the previous when we did our multi-pair cam. It might just be 90 degrees, it might be incredibly obvious, depending on which cam you picked. But certain cams can't be 90 degrees off of each other. And I wanted to explain why and then how to choose what angles you would need to do. So let's go ahead and start constraining these. Let me first show you what would happen if I make them all 90 degrees apart from each other from this pair cam. Now, hopefully you can just take a look at it and it's intuitive and obvious, but let's go ahead and discuss it real quick. Let's click on the two work planes that we would make 90 degrees. Well, this first one will be just 0 degrees off, so I'll say 0. And this next one I can tell to be 90 degrees off of this same one, so 90 off, and then it turns it sideways slightly. And then, well, this next one we can tell, let's see, the work plane's not actually, oh, there it is. I'm sorry, I couldn't find it there. So I'll change my view a little bit so I can see it. I want that one to be 180 degrees off. And you might have already recognized the pattern here, that they look like they're the exact same, and they are. That's kind of the point. And then I'll tell this one to be 270 degrees off. And so now, okay, we got 90, 180, 270, and then 0, which is the same as 360. Then we can quickly add our transitional constraint as well, right? So click on this bottom of our follower to our Ninja Snail Cam and apply, and we'll do the same thing for all of them real quick. So click apply, just keep going. And you might have already realized what problems this would create. But what this is going to end up doing is making all of our Ninja Stars graphs that they would make the exact same, because all the followers will go up as if we picked 0 degrees. So you see how they all go up together? We might as well just picked the same angle or just mated them all to the graph, because of course it would. Because this is, if you look at it, these are, symmetrical every 90 degrees. That's the whole point. There's 4 of them, there's 360 degrees. So if there's 4 of them, it's 360 degrees. That means every 90 degrees, it's the exact same. So they end up being the exact same. And so that wouldn't be a good graph. It would just look like, our Ninja Snail Cam by itself. It would just all go up at the same rate and then drop at the same rate. It wouldn't be inconsistent. We wouldn't have every few angles a different graph based on the cam that we're looking at, or the follower we're looking at, I guess is what we should be saying. So we need to update those angles. So these aren't necessarily the best angles. So if you think about it, how I would figure it out is, I'd keep angle 1, I'd keep the first one at 0 degrees, but I'm going to go in and edit these, and where am I getting them from? Well, they're all on the axle handle, so that's where I'm looking for these angle constraints that I just put down. But I'm going to change the second one from 90 to 1/4 of 90, let's say. So I say 90 divided by 4. And so that would give me 1/4 off of 90 degrees, or if you look at it, 22.5 degrees. And so now if we look at that, what would happen? Well, the second one is going to go off a little bit after the first. And of course, these two are still the same as the first, so they're going to continue to go up with the first. But you'll notice that the second one goes up a little bit after the first. And so they don't go up at exactly the same rate. Then I can do the same thing for the angle 3. I can edit that one to be, instead of 180, we could say 90 divided by 2, or half of 90, which again makes sense. So, and then we can do the exact same here. This could be 3/4 of 90. So how would I type that in? Well, Autodesk is a computer software which has a calculator in it, so I can just type it in, 90 times 3/4. Since I'm bad at math, I'll just let Autodesk figure it out. And you can see, well, now they're all going to go up at inconsistent rates. They're going to go, the first one's going to go up, and the second one's going to start going up immediately after, and the third one's going to start going up after that. And you can kind of see it happening. It's kind of, I don't know how to describe it other than they go up in consistency. They go up at different rates, but they're still following the same pattern, more or less. Just they don't go up at the same time, which is kind of the whole idea. And that's why I chose these angles that I picked. If I picked 90 degrees, we get what we saw earlier, right? So I'm going to go in between 90 degrees. And so every 25% of the way between 0 and 90 degrees, the next one goes up. And that would be a good way to start to make sure that they all go up in a consistent, measurable pattern. The only problem with choosing these angles is, if you look, we don't have those angles to work with. We don't have 22.5 degrees. We have 45. We don't have 67.5. And we could fix that by changing these and making this a little bit less readable, a little more convoluted and detailed. But I don't really see the point of that. The whole point of this is to get these graphs that vary, these 4 different graphs that vary. And so let's go ahead and use those angles to our advantage. So instead of going up at 22.5, let's tell the second one to go up at 15 degrees. So I'm going to change this, instead of 1/4 of 90, I'm going to tell it to be 15 degrees. Let's see how that changes our graph. So, okay, it's actually looks very similar. Of course it does. It's only 7 degrees off. And I can leave this one at 45 if I want to, or I could change this one to 30 and make the last one 45. I'm going to leave this one at 45 degrees, and I'm going to tell this one to be, let's see here, instead of 67.5, maybe I'll choose 75, or even 60 degrees. But I'm going to choose 75 because I like that. So we'll say 75 degrees. And let's see how that changes. Well, again, now they're going up at a different but measurable rate, which we can create in our graph. So the first one is going up, and then the second one starts going up immediately after, and the third one starts going up immediately after that, and then so on and so forth. And of course, again, I can make this one 30 degrees instead of 45 if I wanted to, and then I can make this one 45, or I could, well, let's look at what that does. Or there's all kinds of different ways I can do these based on my measurements here. But the point is, hopefully you see why I chose the angles that I chose, and why it's necessary that sometimes they aren't every 90 degrees like they were in the PearCam. So hopefully this video helped. And of course, if you're picking one that's not symmetrical every 90 degrees, then this video probably might not have been too helpful. Although certain ones aren't symmetrical every 90 degrees, and this still would have been helpful, I guess. Like the StarCam, for example, you would want a more consistent, I guess, I don't know, visually appealing graph that's measurable. You can measure the angles. But hopefully this made sense, and it helps you making your own multicam assembly and accompanying graph.